Okay, so we are going to be using some probabilities to make some predictions. Here's one of the most simple ones that I could think of. I flip a coin 100 times. How many times do you think it will land on heads? 50, right? Because that is a really easy prediction. Flip a coin and land on heads. The probability of a coin landing on heads is 1/2, right? If I flip it 100 times, then it should land approximately 50 times because that's half of 100. That's using probabilities to make a prediction. We have a couple problems where we're going to use probabilities to make predictions. So here we go. George has a spinner. The probability of landing on green is 3/8. What does that mean? What does that mean? If the probability of landing on green is 3/8. Yeah, Emery? Exactly. On that spinner, there are 8 spaces and 3 of them are green. If George spins the spinner 108 times, how many times should George expect the spinner to land on green? There are 2 good ways of doing this problem. Okay? Let's start off just by thinking. If I spin the spinner 8 times, how many greens would I expect? 3. If I spin the spinner 16 times, how many greens would we expect? If I spin the spinner 24 times, how many greens would we expect? Do you see what I'm doing here? That seems like a really tedious way of doing this problem, doesn't it? Adding up 3's until I get the denominator to be 108, that's not a very successful way of doing this. There are better ways to do this. And we can equate the probability stuff that we're doing to the percent stuff that we did before. There were 2 ways to solve percent problems. Anybody remember those 2 ways or one of them? I said, I don't care which one you use as long as you use one of them. Do you guys remember how we would solve percent problems? What are you going to say?
Like, is it, I don't know if it's a POW or is it the, like, equation or?
Yeah, that's one way. So a POW. Remember a POW? Well, I got the power. Right, one of those. A POW or POWA is a really good way of doing these problems. So I'm going to do a POW because to me that's the one I remember. Okay. I'm going to try writing that again. However, in this case, P doesn't stand for percent. What does P stand for?
Amount.
It stands for what?
Amount.
Well, it can't stand for amount because A stands for amount. P stands for probability. So what's the probability of rolling a green or of spinning a green? 3/8. So if P stands for the probability of spinning a green, A means the amount of times I expect to get a green. Remember, P and A are tied together. What's W stand for? Be the total, right? The amount of times you spin, the total number of spins, so this would be 108. Now we should be able to do this one without a calculator or without a whole lot of work because you can pretend that there's a 1 under the 108. And 8 goes into 108 how many times? This is where you use a calculator. 13.5. Okay, so maybe that wouldn't be a good one. If we could factor out a 4. Or we can just multiply. Use your calculator. 3 divided by 8 times 108. And we get 40.5. So about 41, right? Now there's another way we can do this problem as well. Going to be honest with you, this is the way that I always do every single probability problem. I'm telling you, this is the way that I prefer. Other people like to set up a proportion. Remember, by definition, probability is the amount of success over the total. Right? That's what probability is. It's the number of successes over the total number of possibilities. So 3/8, right? There's 3 chances for success out of the 8 spots. That's what Emery reminded us. This probability means that there are 3 greens out of the 8 total number of spots on the spinner. Well, what's the total? 108. That's the total number of times. So how many times will it land on green? I don't know. This is the other way you can solve this problem. You can solve it using proportion. Remember when we did percents, you can solve it using the percent proportion. How many people were proportion people, you guys remember? Remember I had like 3 or 4 in this class, not too many. Yeah, there were some proportion people. Well, I could solve this one using a proportion as well, right? And what would we do here? We would cross multiply. 3 times 108 is 324. X times 8 is 8x. Divide both sides by 8. And we get 40.5, or about 41. Same problem, different way to solve it. Okay? You pick which one you like. I'm going to be honest with you, I always like this one. With probabilities, to me, it makes more sense. 3/8, okay, so 3/8 of the spins should be green. Are 3/8 of the spins going to be green? Probably not exactly 3/8, but it should be pretty darn close. Probability, number of times, that's how we make a prediction. Okay? Predict it by just taking the probability of the number of spins. Let's do another one. All right, let's stick with spinning, but now we're at a festival. We're at a festival. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 18 sections, so it tells you how many sections there are. How many sections of the wheel have a bobblehead as a prize? How many sections of the wheel have a bobblehead as the prize?
3.
Why?
Because there's 18 sections, so 1/6 is simplified, so it'd be 6 times 3 is 18.
6 times 3 is 18, or 18 divided by 6 is 3, or 1/6 times 18 is 3, which is actually the problem. This is actually what's happening. That's the math behind it. But many of you understand that 1/6 is the same thing as dividing by 6. There are 3 sections. 3 sections have a bobblehead. So we want to figure out, hey, how many bobbleheads should the festival buy? Should they buy one for every person?
No.
Probably not. Why? Because we would lose a lot of money, right? Is every person going to win a bobblehead?
No.
How many people are going to win a bobblehead? 1 in every 6. So we can estimate how many bobbleheads we'll need to buy based on attendance. The prize wheel is spun 540 times. About how many bobbleheads do you expect to be won? Well, for me, I use a pound. What's the probability of getting a bobblehead?
1/6.
How many times is it being spun?
540.
I'm going to tell you right now, this question would be given to you without a calculator. This would be a no calculator question on your island. So do this one without a calculator. How do you multiply fraction times a whole number? No, we don't make any decimal. Put it over 1. Now, 1 times 540 is? 6 times 1 is? So how many times does 6 go into 54? How many times does 6 then tack on a 0? How many times does 6 go into 54? With a 0 at the end? So how many bobbleheads do you think the festival should purchase? Like 100? This is a prediction. Is it going to be 90 people winning?
No.
Probably not. It's a reasonable prediction, though, based on the probability. Probably should buy like 110. 120 to be super safe. There aren't going to be very many more than that. You make predictions by doing multiplication. You take the probability times the number of times it's going to happen. Let's do one more. So we're sticking with theoretical probability. We'll do one experimental probability problem. Theoretical probability of randomly choosing a red marble from a bag is 5/8. There are 40 marbles in the bag. So, how many red marbles are there?
25.
How do you know?
Well, 5/8 is simplified, and then if you denominator 40, so 8. is 40, 5 times 5 is 25.
So Olivia said 5/8 would just be a simplified version of something over 40. That's what she said. She said, well, 5/8 is simplified, and there's 40 marbles in the bag. So then she said 8 goes into 45 times. That would be a common multiplier method. I'm just writing the math behind what Olivia was thinking. Right? This is just the math behind it. Not how I do it. It's a great method, though. 5/8 is simplified, so it's out of 40. How many out of 40? The way I do it, I say 5/8 of the 40 marbles are red. So I put that 8 and 40 have a common multiplier, one common factor of 8. So 1 and 5 gives me 25. To me, I read this as 5/8 of 40 are red. 5/8 of the 40. All right, you randomly draw a marble and replace it. About how many times can you expect to draw a red marble in 56 trials? How can we set this problem up? We're making predictions. We're using the probability to make a prediction. You randomly draw a marble and replace it. How many times can you expect to draw a red marble? What's the probability of drawing a red marble? What's the probability of choosing a red marble? 5/8. How many times are we trying? 56. Do you see a pattern yet? This one you can do without a calculator as well. Put it over 1. 8 and 56, what do they have in common? 8 and 56. You can pull a factor of what out of them both?
7.
You can pull a factor of what out of them?
7.
You can pull a factor of 8 and be left with 1 and 7. So we get what? 35 times. Ladies and gentlemen, the pattern is this. Take the probability and multiply it times the total number you do. It's that simple. That's how you make predictions, right? Remember when I said half of 100 and you all told me 50? Because you did 1/2 times 100. Now, what if we're doing an experimental probability? What's going to be the difference? Great answer. You are all 100% correct. Nothing is different. It is the exact same process. You need to figure out the probability and then multiply it times the number of trials. Or multiply it times the total that you're looking for. Bag contains 50 marbles. You randomly draw the marbles from a bag, put them back, and this is the probability. This is how many times we drew those marbles out. It says frequency. We learned yesterday that that means the number of times something happens. Okay. The table shows the results after 30 draws. We want to predict the number of red marbles in the bag. There are not 9 red marbles in the bag. That's not it. What does this 9 represent? What does that 9 represent in this problem? How many times what? How many times we drew the red out of? How many times we drew the red out of what? Out of the bag? 30 times. Why 30? Because 30 is how many times we reach into the bag and pull out a marble. So the probability of getting a red is 9 over 30. Why? Because we drew the red 9 times out of the 30 possibilities, right? Out of the 30 trials. That simplifies to 3 over 10. Your homework is the worksheet that you picked up and to finish your column. That's our probability. Now, a pow. What's the probability of getting a red? Hey, up here. What's the probability of getting a red? 9 over 30? Or 3 over 10. It doesn't really matter which one you do. I'll do 3 over 10. How many marbles are there in the bag? 50 marbles. This is definitely a no calculator question. Because what can we do? Put over 1, and do what else? We can cancel a 10 from both of these. And we're left with 15 red marbles. Now, are there 15 red marbles in the bag? We don't know. It is a prediction based on the probability. So what did we do here? We need to figure out the probability of getting a red. This was the frequency after 30 draws. So the probability was 9 out of 30. It's an experimental probability. Remember, experimental and theoretical are different. Experimental probability is the number of successes over the number of trials. There were 30 trials, 9 of them were red. Then we use our equation. Probability times the number of things we're looking for.